This is a video tutorial for tutorial 5A, question 7. Question 7 asks us to find dy dx given that sine inverse of x plus y is equal to x times y. So we're very tempted at this point in time, because we now know how to differentiate sine inverse, to just go right ahead and differentiate this equation. However, that would be a mistake. Whilst we know how to differentiate sine inverse, that square root that it gives on the bottom line is quite nasty. It's not something we want to have to deal with. So to avoid it, we've got a very simple workaround. We just move the sign to the other side. So that if sine inverse of x plus y is equal to xy, that means x plus y is equal to sine of xy. And this one's much nicer to differentiate. So we'll differentiate both sides with respect to x. And what do we find? Differentiate x, you get 1. Differentiate y, you get the derivative of y with respect to x, dy by dx. Right hand side, outside to inside. Differentiate sine, you get cosine xy. Times. Differentiate xy, we need to apply the product rule. So hold x constant, differentiate y, we get dy by dx, plus hold y constant, differentiate x, we get 1. So this is our expression for after differentiating both sides. We want to isolate dy by dx to get an expression for dy by dx in terms of x and y. So first thing I'm going to do is I'm going to expand out the right hand side. So I find I get x cosine xy times dy by dx plus y cosine xy. Now I'm going to bring everything with a dy dx to it into the left hand side of this equation, everything without to the right hand side. So I get dy by dx minus dy by dx x cosine xy equals to y cosine xy minus 1. Factorize out dy by dx. I get dy by dx 1 minus x cosine xy is equal to y minus y cosine xy minus 1. And then dividing through, I get dy by dx equals to y cosine xy minus 1 over 1 minus x cosine xy. And that is our expression for dy by dx.